Should be showing now. All right. Good evening, everyone. Welcome to our presentation for tonight. It's the first virtual we've hosted for the AIAA Central Florida Section. So we're really excited to start this out, and we have a few more great events coming that we'll tell you about before our speaker joins us. So first, just to give a quick introduction about our organization. If you're not familiar with the American Institute of Aeronautics and Astronautics, it's the largest aerospace professional organization in the world. We have members from all across the country, primarily focused in the United States, but we do have a section that covers the rest of the world. They host some of the best industry-leading technical committees and forums where people from all sorts of companies and institutions come together to discuss aerospace and the future of technology. Coming up soon is actually going to be a really cool online event, the Ascend Forum, which is open to anyone and is actually cheap this year because it's going to be only online. You don't have to worry about traveling to the location or anything. Coming up November 16th through 18th. So if you're interested in space, really anything space related, it's going to be covered at the Ascend Forum. Presentations from people like the administrator of NASA, people from SpaceX, and all the great companies out there. The Central Florida section is our local group here in the Orlando, Central Florida area. We cover out to Tampa, up towards Gainesville, and a little bit south as well, which you can see on the map on the screen. And we serve the local aerospace community in our area. We have a lot of different companies and institutions here that do great aerospace work. So our job is to help support them in any way we can to help grow careers and support the industry, as well as growing the next generation of aerospace experts, whether it's educators or engineers or scientists or anybody that's in the area. And we work with our two student branches at the University of Florida and the University of Central Florida to help them. They have hundreds of active students between the two schools that do a ton of great projects, building rockets and airplanes and learning how to be engineers and really learning to apply that stuff that they're learning in school so that they can start a great career. Sorry, I skipped a page. So who are we, the people involved? We recently had our election, so our new council for this year is going to be myself, Chris Stevens, the chair for this year. Returning as our vice chair is Walter Hammond. And we also have Jason Mulligan as our treasurer this year, and Christian Wichkowski, I'm going to butcher his last name, as our secretary. And we also have Dr. Mike Kinzel joining us this year as our new STEM and K-12 coordinator, and as well as Emma Turner at UCF and Jose Aguilar at UF. So if you have any interest in it, please feel free to contact us, and we're happy to help out learning more about our group. For upcoming events, we have an aerospace resume and interviewing workshop, which is aimed at college seniors that are getting ready to put in their applications to go into the workforce. But it's also great for people looking for internships or any professionals that are looking to brush up their resume to look for a new job. And again, it's aimed at aerospace, but it really is knowledge that can be used everywhere. And that'll be another virtual event here on YouTube coming up October 21st. So that's open to anybody. If you're interested in watching, come by the channel. We'll also have a missile design development and systems engineering course presented by Gene Fleeman coming up in early November. And we're also going to be sponsoring the SECME glider competition regional championships at UCF this spring. So we'll be looking for a few volunteers to help out. We're going to be teaching elementary, middle, and high school students about the basics of aerospace, building gliders, and then they're going to come to us for the regional competition that we're hosting at UCF in February. If you're interested in learning more about our organization, we have some websites listed here. engage.aiaa.org/Central Florida is our main primary webpage. We also have our Facebook page at Facebook AIAA CFL and our YouTube channel, which you're watching on now. And we do live streams as well as posting previous events, including some of our in-person events once we get back to doing those as well. So tonight's event is really exciting. We have Christopher Wanjek here, who is an author and a health writer who's written several articles on human health, as well as his two books, Bad Medicine and Food at Work. He's also written a lot of articles on space exploration, including the Armchair Astrophysicist column for Mercury Magazine. And tonight, Chris will be telling us about his latest book, Spacefarers, about human space exploration and how we're going to settle the moon, Mars, and beyond. So thank you, Chris.
Okay, over to me.
Yes.
Okay, let me share the screen.
Yes.
How's that coming along? Okay, and presentation slideshow. Bang, we all set?
Yes.
Okay, looking good. Hey, no, honestly, thank you very much for this opportunity. I'm actually quite humbled to be speaking to this kind of audience, and I'll confess a little bit nervous. I mean, it's you type of people that I went to write my book, the aerospace experts and physicists and engineers. So for me, it's a bit like a dissertation I'm giving in front of the board at this point. I'm going in front of the experts to tell you what I found. So a little nervous in that regard. But again, very humbled to be here. And so I looked in to see what you guys were all about, and I was very impressed by your mission and your tagline, your credo, which has words like "we work in the uninhabitable, dream the impossible, chase the unattainable." And I said, "Wow, that's great," and I could relate to that because as a writer, I like to relate that kind of excitement to other people. I like to relay the work that people like yourself are doing. Um, so I was very impressed by that, and I'm very excited about space in general. So I'm not a complete novice to this. That I am indeed mostly a health writer, but I did work at NASA Goddard Space Flight Center for about 10 years, and I had this great, enviable title. I was the senior writer for the structure and evolution of the universe. Okay, so that's a pretty serious title. People were kind of scared of me. I figured my supervisor was a galactic overlord. But that's where I really started getting excited about space. And then I had this opportunity to write a book about space habitation, space colonization, settlements out there. And I wanted to do this from my perspective as a health writer, a health reporter, and a researcher, but also as a skeptical journalist, because I've always, questioned some of these ideas that are out there. This idea that we can do more or less live on any given planetary body, but is it, although it doesn't break any laws of physics, how feasible is it? What is the motivation, the economic motivation, the emotional motivation that would bring us out there? That's a big question, I think, that gets glossed over. So I think there's going to be lots of opportunities in space, lots of really interesting things we're going to do, and then really things we're not going to do. Let's face it. So let's go through them. I want to know how we're going to get to the moon like this, or on Mars, or in these great orbiting cities that are above in low Earth orbit with artificial gravity, or even to exotic places like Venus floating above the clouds. Maybe you can just drive there, right? It's a great picture, isn't it? This is an actual real picture that used to be a red Telsa. It's a little wear and tear on at this point, and that's a mannequin driving it, Starman, on his way to Mars. It was launched by SpaceX, famously, February 2018. It's almost at Mars now. In fact, it's going to overshoot Mars. They wanted it to be in Martian orbit, but they got the trajectory a little bit long, yeah. And so it's going to pass Mars a little bit. That just shows you how tough this kind of stuff is, but really neat shot. So before we talk about what we can do out there, I'd like to talk about, why we're going to go out there. Because people are talking about that we have to get off this planet Earth. There's this idea that we have to be a multi-planet species in order to guarantee the existence of our very human race, right? That something terrible could be happening to Earth, and then we have to be on another planet to protect us. And I just think that's a ridiculous idea, to tell you the truth, because I can't think of any doomsday scenario that would make the Earth worse than any place else in the solar system. Honestly, I mean, let's go through these one by one. The big thing is the population overload. There's too many people on Earth. Well, first off, offloading 1 million or even 1 billion people to Mars, however impossible that's going to be, that's not going to change anything on Earth. And actually, the population is going to start stabilizing. That's what we're seeing now. Yeah, about 8 billion people on Earth today, maybe 10 billion by 2050, 11 billion by 2100. But it's starting to stabilize at that point, and that's natural as wealth increases and female literacy increases, fertility rates drop, and populations level out. So there's not going to be too many people. And that's not the problem, is it? I mean, as engineers, you can appreciate it's not about too many people, it's too much waste, too much inefficiency. Think about the food waste in this country. 50% of food is just wasted. The power grids, 10 to 50% is just lost in the transmission. All the methane that we don't capture, all the fertilizer we don't capture. We have these manure lagoons. You got fertilizer where we don't want it. Incredible inefficiency. And we can hold many more people on this planet if we learn to be more efficient. I am pro-life in that regard, that I like to see billions more people here, because more people mean more ideas, more entrepreneurs, more inventors. I'm all for people. I don't see why we have to limit the population or move elsewhere because there's too many people here. Living in space and going to space for space resources is going to enable us to have more people on Earth. Okay, the pandemic, well, we're in one. It's horrible, I know. I personally know 2 people that have died in this pandemic from the coronavirus. So it's horrible. If we had done nothing, several million people would have died, which is not, a pleasant thing at all. But viruses, bacteria, they've never wiped out humans before. And why would they wipe us out now in this era of DNA sequencing and vaccines? So I don't see any type of virus as being a threat to the human race, that we would have to be on another planet to be protected from it. Nuclear war, horrible, quite possible. I'm not ruling that out. Most people would die. A few 100,000 to 1 million would live in underground shelters, and they could start life all over again. That's very well known. It's not going to be the end of the human species. Asteroid strike is just about the same as a nuclear war, isn't it? Some people will survive, but the thing is, we're smarter than the dinosaurs, right? We can see it coming and we can deflect it. That's the great irony, the silly logic here is that if we were on Mars, completely independent and not needing Earth, then we would have the technology to block any asteroid. And we're almost there now. Likewise with gamma ray bursts, this is a very well-known theory, but it's a very good theory that 450 million years ago, there was a gamma ray burst, which is a massive star explosion, bigger than a supernova, a hypernova, aimed in our direction, a jet of gamma rays coming barreling at us. This happened 450 million years ago. There's good evidence for this. And it destroyed the ozone layer, and it converted the nitrogen and oxygen into nitric oxide, acid rain. It wiped out 90% of life on Earth. And if that happened now, there's no warning. Unlike an asteroid, the flash of gamma rays is your warning because it's traveling at light speed. But the only comfort here is that when we look around the galaxy out to 100 light years, there doesn't seem to be any star close to going hypernova. So we're safe from that one. And climate change, I think, is the greatest threat to life on Earth, absolutely. But there are engineering solutions to that. Things will get worse, but they will get better. But it's not going to wipe out humans. And it's the same dumb logic. If you were on Mars and you were able to live on mini Earths on Mars, you would be able to live on mini Earths on Earth. If you could terraform Mars, you could terraform Earth back to where Earth used to be. So I don't think there's any threat there. Oh, here's the one threat that I see. The Vogon construction fleet vaporizing Earth to build a intergalactic superhighway. It was the theme of Hitchhiker's Guide to the Galaxy. Can't prevent that. Just, we're doomed. Fingers crossed is all I can say about that threat to humanity. So why go out? Why? This is why I think we should go out, because literally the sky is the limit. We can make life better on Earth by tapping in the space resources and moving out into space. Think about it. You could augment energy production with solar panels in space, of course. You can do the nuclear fission on the moon, where it's much safer. You could offload supercomputing. That's a huge energy loss to us. And it's be far more efficient to do it up in space, where you can get down to temperatures like 40 Kelvin or even 4 Kelvin. The computers will be much happier up there, much more efficient. You could offload the worst kinds of mining, not every kind of mining like iron and such, but the rare earths, very polluting, uranium mining, even cobalt to some degree. You could get that out towards the moon. And you can enable, of course, all types of space-based manufacturing, these useful molecules that you can do in microgravity, crystals, semiconductors. All this is going to have an amazing impact on the quality of life on Earth. And we can only do that by venturing out into space so that we can live better on Earth. That's why we're doing this. And of course, all the fun stuff that we're going to talk about in a second, the tourism and the space exploration. But here's the biggest problem: getting off Earth, right? That first, the first 100 kilometers is a doozy. Once you get past that, then things get a little easier, but you're up against this rocket equation, the famous tyranny of the rocket equation that's more or less saying, if you want to get off Earth, you're going to need fuel, but the fuel carries weight. So if you want to get more mass on Earth, you have to add more fuel, but that adds more mass to the rocket. So you need more fuel, and that adds more mass to the rocket. So you get this cycle going where you can only launch so much off the Earth with chemical rockets, chemical rocket fuel. And if the Earth was just a little bit bigger, maybe 1.5 times bigger, you wouldn't be able to launch rockets at all because the gravity would be too strong to escape Earth's pull by these rockets. So we have to come up with other ideas. You can't do much, as the rocket equation is pure physics. You can't really tweak that equation. So how else can we get up on Earth? Well, I do think there's market efficiencies, capitalism at play that can ease the economics of this, of launching into space. And I think Elon Musk, for one, this audience probably has strong opinions about the guy, but he has lowered the cost of access to space by a factor of 10, depending on the type of launch you're talking about. I do think there's some radical new fuels on the horizon, one of which is metallic hydrogen, thought to exist only in the core of Jupiter. Metallic hydrogen, not liquid hydrogen, metallic hydrogen. And they did this at Harvard by squeezing hydrogen with a diamond anvil until it became metallic. So if they could stabilize this and produce it in high volumes, it would have a tremendous kick. I mean, the exhaust velocity now of these basic rocket fuels is 4 kilometers per second, but metallic hydrogen would have 16 kilometers per second. And you could launch all types of stuff at that point, entire buildings. Nuclear, dare I say it, that was actually tried. I don't know if you know about the secret Project Orion in the late 50s and the 60s, where they were going to send rockets via atomic bombs. That would be your force. And Freeman Dyson was behind this. And this is these guys on the beach here in California near San Diego have a little sample. And that took off in the air with a couple mini nuclear bombs. His idea was to have Freeman Dyson 20,000 nuclear bombs, and that would have an exhaust velocity of 200 kilometers per second. It will get you to Mars in like 2 weeks if you could survive the G-forces. That was part of the problem. But yeah, you probably can't do that on Earth, but maybe you could have nuclear rockets on the moon where the danger is not a worry, and then blast off to Mars that way in some nuclear rockets. Space planes, I think, is a waste opportunity. There's not enough funding going into them. Maybe this crowd can appreciate that. There's an interesting plane made by a UK company called Skylon, a single stage to orbit space plane using a combination of scramjets and such. Very little funding. It's going nowhere for the past 30 years, unfortunately. Then, of course, the Air Force has that secret space plane. Maybe some of you know about the X-37B. Maybe some of you know about it and are allowed to tell me about it because they had 4 secret missions. But I don't know what the Air Force is planning, but they have some type of space elevator, space plane in the works. So that's the next thing, these radical ideas, like a space elevator you may have heard of. Feasible, yes. Practical, I'm afraid not. So right now it's not technically feasible, but it could be. This space elevator, you might know, is you would have a counterweight at geosynchronous orbit attached to the Earth, held taut by centrifugal force as it's whipping around, all in place. You need a strong cable for that, and there are no cables at the moment that could support that, not even Kevlar. The only thing close would be carbon nanotubes, but the longest carbon nanotube is a thread that's about, what, 0.5 meter? And you need 36 million meters to reach geosynchronous orbit. So, but hey, someday we might be able to produce that much carbon nanotube, but then what? Where do you put this thing? That's the problem with the space elevator. How do you protect it against terrorism, A, and the space junk? This is a pretty clean picture you're looking at with not a speck of space junk down there, but there's space junk all over the place. It's going to be whacking into this and making the whole thing unstable. It's just too daunting. It could work on the moon and it could work on Mars, even with Kevlar, but it's not worth it on the Earth because there's better ideas. Like this one, I love this one, the Haskell system. They're sky hooks. They're essentially hooks dangling from orbit with a hook that you can reach in a suborbit range. Quite feasible, Boeing tested this system, mathematically, and found that all the materials exist today. The technology is here today to do it, where you just send your cargo via, or even people via space plane or a sounding rocket attached to one of these tethers and let it get carried up into orbit. There's very little energy to continue to support these hooks that are just floating around in orbit once you get them up there. It's just a matter of investing in it when we have more need to go to space. Same as this brilliant concept. It sounds fantastical, but it's pretty practical when you think about it. If you want to have people in space, lots of people, lots of things, each and every day going to space, then you're going to have to get away from rockets and go with something like this. It's an orbital ring, a ring around the entire planet, yes, but it could be done in parts. You have metal tubes that are sent into orbit and connected together, little by little until it eventually gets around the entire Earth. And then it's good to go. It's already moving in orbit. It's not going to come down. Then you could put an electrical current through this, okay? And then you can make someone like a maglev platform. You can float something on top of this ring. It would be like a maglev train in reverse, if you can picture that, right? Where the ring is the rails, and they're moving really fast at orbital speed, but the platform's like the train carriage that's just sitting there still, though, and as the ring is moving underneath it. So you could stand on that platform. You'd be high up. You wouldn't be in orbit. You would just be high above the Earth. You would feel most of the Earth's gravity. You wouldn't be in free fall. And then you can haul things up that way to get things. You can even have space planes on platforms up there that could just take off to the moon that way. You could launch from up there simply by going up a cable. All the materials exist to be able to do this. Be a tremendous investment, trillions and trillions of dollars, yes. But if the price of space access comes down, maybe you can get this down to $1 trillion. Still a lot of money, but remember, the interstate highway in the United States, that cost $500 billion to build. But it was an incredible investment. It's said to have paid 6 to 1, $6 back for every dollar invested because of all the commerce that it enabled. That's the idea here. Once we get more activity in space, there's going to be more demand for space. And it's just going to make sense at some point from a commercial perspective to create the infrastructure, the highway into space, if you will, to enable the commerce to happen that much more efficiently. So we do have a growing presence in space, and you wouldn't know it from this picture, the ISS. Right now, there are only 3 people on the ISS. Can you believe it? 3 people. Sometimes it has 6, that's true. But a total of only 220 people have been on the International Space Station. And the cost of this thing was $150 billion, and it costs $4 billion to maintain every year. That means for each person we sent there, we're spending $500 million. $500 million per person sent to the ISS. This is not sustainable. We need something better, and that's coming along. It's expanding as we speak. This is from 2016. This is called the Beam. It's an expandable habitat made by Bigelow Aerospace, and it's attached to the ISS, flown there by a SpaceX rocket. That just shows you the cooperation between business to business, which is really exciting about space, isn't it? Not just government to military anymore. Okay, you got real business to business activity. So Bigelow attached this in 2016. It's still there today. It's being used as storage. It's a little thing attached to the space station, but he's got bigger plans. These things would be free floating, so to speak. These are called the B330s. B stands for Bigelow, 330 for 330 cubic meters of volume, which is bigger than any place, any living space on the ISS for 1/100th of the price. For 1% of the price of the International Space Station, you can launch one of these expandables up there. So, can you imagine that? You can use it as a hotel to visit. You can use it as a factory up there. A company could set up a lab in one of these things, send that up into space for only, $500 million maybe. It's a big investment, but they could start finally really manufacturing in microgravity. Or the hotel concept, I think, is brilliant. It's going to cost a lot of money, of course, at first, several tens of millions of dollars for a rocket to go visit one of these hotels. But the price will come down. You can imagine movie producers, music video producers wanting to take advantage of this to film in space in real microgravity. That would be pretty cool. In fact, Tom Cruise has already said he wants the next Mission Impossible movie, part of it filmed in one of these Bigelow's expandable hotels, expandable habitats. And this is all going to happen mid-decade. It's very exciting stuff. So let's now jump. That was low Earth orbit essentially, and that's where we've been hanging out for a while. Let's jump over to the moon and then Mars. Excuse me. Okay, so I think the best way to start learning how to live on the moon and Mars is to study Antarctica, study what they're doing there, because there's this amazing parallels between Antarctica, the moon, and Mars. I mean, obviously they're both cold, hostile, remote, monotone, isolated. There's flights in Antarctica for 6 months a year, you can't get a plane in there. So you're on your own for 6 months, right? Some of these bases only have 4 to 8 workers for 6 or 8 months. That's like a Mars mission right there. You can study the stresses of such a small group of people in a small little indoor place. You can't get outside of the South Pole in the wintertime. So fascinating stuff going on. And you have to bring all your own food, of course, don't you? And you can try to grow food down there, and that's what they're doing. Germany and the US have these grow chambers at the South Pole, completely sealed, growing food with LEDs. They're practicing for Antarctica, but it's really practice for the moon and Mars, if you think about it. Let me just race through some of these parallels because I just think they're fascinating. When you think about Antarctica, how we first got there around 1900, but it took about 50 years before technology improved until we could set up bases. And look at that on the moon. 50 years later now, and we're talking about bases, and we're talking about going back for good. Both are organized by treaties, the Antarctica Treaty and the Space Treaty governing the moon. You have permanent residents on permanent research bases on Antarctica, operated by countries where you got scientists going down for a couple months a year, and then there's a year-round crew, kind of a rugged year-round crew that might stay there for a couple years. Same things can happen on the moon, and you're going to have country-based bases and people visiting for a little bit with a year-round crew for maybe a year or two, because no one's going to live there. That's one of the big things here. Amazing science that can be done, same kinds of science, and as I said, no one really lives on Antarctica. They always come and go. Same as the moon. I can't imagine anyone living permanently on the moon because there's just no attraction. You can go there for work, but to raise a family there, to colonize it, to settle it, it's just not feasible because I can't imagine you were going to be able to raise children there in 16, 17% gravity. We'll get to that in a second. And here's the last mind-blowing similarity. Where do you go first on the moon? You go to the South Pole of the moon. That's the best place to set up camps. The equator is not ideal on the moon because of the extreme temperature fluctuations. You have these 14 month, I have a weak connection here. Hopefully I'm back. Okay, so we have a 14-day night and a 14-day day. And then in the day, it gets up to like 130 degrees Celsius, which is boiling, over boiling. And then in the night, there's no atmosphere to circulate that heat. So it gets way down to a minus 170 degrees Celsius. So that, that's not fit for man or beast or even machines, that no one can endure that kind of temperature extreme, very challenging. But the South Pole, because there's no tilt on the moon, the South Pole is constantly getting sunlight. And there's a stable temperature down there of about minus 50 degrees Celsius, which is bearable, right? And it doesn't fluctuate. And there are parts of it on some of these craters that you see here. Let's see if I can use this. Yeah. So some of these craters have points of eternal light. They're that high up. And that means you could have constant solar power with no downtime. That would be amazing. And then some of these shadowed areas, these shadowed craters, they contain ice. Ice you can melt to drink, of course, is in forms of water, but perhaps more important, ice that you can use as a rocket fuel, because the H2O could be split into hydrogen and oxygen. So this could be the first commodity on the moon, ice that's broken into rocket fuel. In fact, I have in my notes here, so United Launch Alliance, they are already have said they are willing to pay $500 per kilogram of such propellant on the surface of the moon and $1,000 per kilogram for that much in orbit, because it's that much harder to get to. So that's, and they're going to need 1,000 metric tons. So it's 1,000 times 1,000, that's $1 billion business right there. NASA we're going to want that kind of fuel too. 100 metric tons is what they anticipate for ascent vehicles if they start picking up activity there. So that's a real business model you got going. So this is what it's going to look like at first. What can we do on the moon, you might ask ourselves? Well, I think we have to set up a camp. And this is ESA's idea of you send these kind of airlocks that have this inflatable dome that robots will eventually cover. There's one up here. It slowly cover with regolith to protect the inside from the radiation that you get on the moon and micrometeorite damage. I say this because you need infrastructure. I mean, I'll go on record right now by saying this idea of getting humans back to the moon by 2024 is not only not feasible, but just detrimental to our long-term goals. I mean, that's what was wrong with the space race. The space race didn't have any long-term goal other than getting to the moon. So you spend a lot of money, don't bother with the infrastructure, and you more or less guarantee the position that you can't stay there because there's nothing for you to do and it'd be too hard to stay. What you need to do is that the ESA approach is get the infrastructure set up first and then send the humans. There's no use sending humans just in the name of pride. It's just by 2024, it's just a waste of money in my opinion. But let's say we do start getting there and camp starts building. Again, it's got lots of good science that can be done there, right? Especially on the far side of the moon, you know, where there's no interaction with the Earth. You can't even see the Earth. There's no electric magnetic radiation coming from the Earth. It's completely shielded. So you can have fantastic radio telescopes, infrared telescopes in the cold. So some fantastic astronomy can take place there. And I think this is sustainable too, in the way that we do research on Antarctica. The National Science Foundation has about a $500 million budget to support that. NASA could be doing this with about $4 billion a year. Why $4 billion? Well, that's what it spends each year on the International Space Station. And that's supposed to be, that funding is supposed to come to an end in 2025. And if that is the case, then they could use that money. The moon could be the new ISS. And I think this would be a great idea because I think we should hand over low Earth orbit at this point to commercial activities. Now that NASA and ESA and all those guys, they did such a great job, I think it's time for commercial enterprises to take over that. And NASA and the rest should be going to the moon, put the money there to start establishing infrastructure and know-how so that commercial enterprises can move there, you know, 10, 15 years from now, after they get there. So that's what's happening on the moon. And, you know, is it profitable? Well, you know, that's an open-ended question. You know, is Antarctica profitable for us? It's intangible, isn't it? The knowledge you gain from Antarctica, the sense of wonder, how much is that worth? You can't really put a price on that. Going to the moon, I think you're going to have a lot of that, right? Knowledge and wonder, quite valuable, but no actual price you can put on it. There, about, you know, but in terms of hard cash, well, we talked about the, you know, ice to fuel idea. I don't know how sustainable that is, but in the beginning, you could be doing that. Mining operations, I'll confess, are a bit speculative because a lot of things have to happen. The opportunity is there. I mean, you have all these iron ores, all these different ores like iron, silicon, aluminum, nickel, and this would be perfect for building structures on the moon or in space. But that's the problem. We don't need them until we have committed ourselves to building such structures. And no one's committing ourselves because it's too expensive to get it. So we're kind of in a catch-22 cycle here. And something has to change. We have to make a commitment to start building in space before mining the moon becomes viable. And for those mundane things like iron and nickel, which we certainly don't need on Earth. There are a few things we need on Earth, though, or we could use on Earth. And one is something called creep. Don't know if you ever heard of this. It stands for, the K is potassium, the P is phosphorus, the REE is rare earth elements. And they're heavily concentrated in certain regions. This is close to the polar region, but on the far side of the moon. And well, I think potassium and phosphorus will always be welcome for fertilizers, or kind of in short supply on Earth, to tell you the truth. We're running low on these because of the waste again. So that would be welcomed. The rare earth elements are not rare per se. They're just very hard to mine. They're very dirty to mine, incredibly polluting, yet they're in high demand. I mean, this is this part of the periodic table, this greenish yellowish part. And an iPhone, a single iPhone has like all 17 rare earth elements in it. Right now, China is the major producer of it, simply because they agree to trade off the environment for money. And who can blame them? When you think about, of course, what the United States did to this country and denuded all the forests for timber. I mean, so you can't really blame China for that. But so in order to start mining rare earth elements, there has to be a point where we say it's too polluting for China to say that, in the same way that United States is not mining all its reserves. Australia is to some degree. But that's a hard commitment to make, to go all the way to the moon just to protect the environment. It's a worthwhile thing, in my opinion, but would business be doing that? I don't know. So that's why that kind of mining is speculative. Also, you have a helium-3. It's a fusion fuel. Hydrogen fusion, this is, the sun is powered by fusion, not fission, not pulling atoms apart, but fusion, putting them together. Deuterium and tritium, they produce a lot of energy when you fuse them, but they produce a lot of radiation as well. But helium-3 fuses rather cleanly. It just produces hydrogen and helium-4, which is regular helium. So there's no radioactive particles. You get all the power and none of the pollution. That's fantastic. And it's so powerful, you could grab some from the moon, bring it back. It will be comparable in price to coal here, but without the pollution. And there's been books written. Harrison Schmitt, the second to last astronaut to walk on the moon, he's a big proponent. He's a PhD geologist. And he has calculated how much helium-3 there is and how hard it would take to get back, blah, blah, blah. There's only one problem with this situation, and that's the fact that fusion ain't a thing. We have to be able to make fusion first. We have to make that work and make it get more energy out than we do in before we can even begin this idea of mining the moon for helium-3. I'll quickly go through some hazards. Let's check the time here. So gravity, I had mentioned, we have no idea the effect of gravity at 16-70% on the moon or 38% on Mars. We just have 2 data points, really. We know Earth, 1G, that's good. Well, 0G on the ISS, that's bad. How do these lines connect? How do these dots connect? Is it a linear idea where, half the gravity is half your way to good health? Or maybe, you need just a little bit of gravity and you got good health, or maybe you need a lot of gravity before your health is perfect. We just have no idea because we haven't tested it. The dust on the moon. It's hardly dust. It's a bad name for it. Dust sounds kind of fluffy. This is like asbestos. It's razor sharp and it's everywhere. And it clings to everything because it's electrostatic. There's even fountains of it. It's called electrostatic levitation. It's floating like about a foot above the lunar surface. So just walking outside, you're just getting all this dust, and it's incredibly sickening. It can cut through your lungs. It can cause DNA damage. In fact, the last person to walk on the moon, Apollo 11, Eugene Cernan, he felt that this was like the most hardest obstacle to overcome on the moon, the dust. It's like living in an asbestos renovation area, to tell you the truth, every day of your life. So tough stuff. So that's the scary stuff. Some fun stuff. Well, you can beat the dust in a gondola, fly above it. These things, it would be a fun way, a great way to get across the moon, because you can move rather quickly in a gondola because there's no air resistance, right? And you don't need that much support because the gravity is kind of low. So this would be rather easy to set up. You just need some poles here and there, as opposed to roads that you would be sintering for the buggies, which really can't go that fast. So that would be an excellent idea to get things around. And also a cool idea is this, the mass driver to shoot things off the moon back to Earth. You can do that by on a maglev rail, because the gravity is low enough and there's no air resistance. You can shoot something about 2.4 kilometers per second, which is fast, a little faster than a speeding bullet. But if you go that fast, your object won't go over the horizon or float off into space, and you can send it all the way back to Earth with far less energy than it would take to go just 100 miles above Earth. You could go 400,000 kilometers back to Earth for a cheaper price and lower energy. There are interesting places to live on the moon, like lava tubes. They're everywhere. And some are as large as a stadium. It's like a ready-made habitat. You just have to seal over. There's a constant temperature there. It's cold, minus 20 degrees Celsius, but that's, doable because it's constant and you can control for that. You could be down there and protect yourself against irradiation, and you can even funnel natural light down there with mirrors. So it's a pretty interesting place to think about it, that you could have big, I don't want to call them cities, but major habitats for workers. I just don't think there's going to be many people on the moon to warrant a city. Hotels. So pretty wild idea offered by Baron Hilton in 1967. Was he a visionary? Was he just whacked in the head? I don't know. Maybe a little bit of the both, because so what he did is he created this idea that it would be a Hilton on the moon. And he even drew up a reservation card and a key, not knowing that there'll soon be a day when there's no such thing as reservation cards and keys. He also had this lounge that somehow has an incredible view from Saturn, even as far as away as we are. But this is quite practical. You can imagine if travel to the moon got to the price of $100,000 or so, that scores of people each year would be going there. For a lot of fun, and maybe even visit the Apollo sites, and then play in the low gravity. I envision it maybe like a safari in the 1800s, where not that many people could afford to go, and it's a bit dangerous, but it was enough to support a business. So here's what won't happen: these mega cities, because there's no reason to be there. In science fiction, you have these massive cities, but who is going to go? What is the motivation to go and live on the moon? Because there's some mining that can be done there, and you should come and go. You probably aren't going to be able to raise children, so that just rules out this idea of colonizing the moon. If you can't raise a family there, then that's it. I mean, the best you can do is have maybe, I don't know, a retirement community. If 17% gravity is better on your bones if you have arthritis. But going there and living there, you're committing yourself to never returning to Earth, because the gravity would be too crushing when you come back. And of course, you essentially would be living indoors for the rest of your life. Even when you're outdoors exploring, you're still indoors. You're in a spacesuit. So what does that psychologically feel like when you're never in the wind anymore and in the elements? I don't know how long humans can accept that, living in an indoor mall for the rest of their lives. So I don't see us on the moon in large numbers. Asteroids is a lot like the moon in mining, right? Because a lot of mundane stuff like iron and silicon and such that we can use to structure out there. A lot of ice. And I think that's the strongest commodity on an asteroid. Some are 10% or more ice, and these could be essentially fuel stations out in space. Better than the moon, really. There's something unsavory about using up all the water on the moon just to burn it up in rocket fuel. But there's literally millions of asteroids that you could tap into. This idea that they're worth quadrillions of dollars in gold and platinum, it's kind of silly. It's all hype, because if you bring that kind of platinum, if you bring that amount of gold and platinum back to the United States, obviously, the market will collapse. So you're not going to be a quadrillionaire whatsoever. I'll just leave you with two quick, interesting ideas about asteroids. One is the idea of not living on one, the gravity would be far too low, but living in one. These things are the size of a mountain, right? Some of them. So you could bore yourself to the center, bore out the center, and create a rotating habitat for artificial gravity. And if you have fusion, you have an unlimited source of energy in the water that's there. You can use that forever, just about. So you can have your own mini world with gravity in an asteroid. And you're pretty well protected in there as well. So protected that, this is the really neat part, as you're going around the sun and you got your little nuclear engine going, give yourself a kick. You could go flying off into another star system at 10% light speed. And the asteroid itself would be protecting you from any type of cosmic rays or meteorites that are coming at you. So you could reach the next star system, Proxima Centauri, in about 40 years, which is a lifetime. That's an incredible concept. I don't know when we'd have the technology to do this, but it is quite feasible. The other idea would be our segue into Mars here. And that I told you that some of these asteroids have lots of water, lots of volatiles. So if you can coordinate, if you can hijack one and send it to Mars, and so that it just skims across the atmosphere of Mars, it could release all those volatiles and build an help build an atmosphere on Mars, which would be certainly much needed. The engineering, I'll leave up to you guys. I'm sorry, quite complicated, but it's feasible. Okay, so Mars is neat because it's the only place, really, the only land in the solar system which we could possibly settle because of the gravity situation. All these other moons, the gravity is too low, and Venus is too hot. So only Mars could we actually have a settlement with families if the gravity is enough to support raising a child. And it's very much, it looks like Earth. It has a 24-hour day-night cycle. There's seasons, and it has every single element that we need for life. The problem is getting there, right? It takes right now 6 to 9 months. Solutions would be to get there faster because the trip is so dangerous. It's particularly in terms of the radiation. We got solar radiation and cosmic radiation. The cosmic radiation is coming from beyond the solar system. And these are very energetic particles. They're so energetic that the Apollo astronauts on their trip to the moon, they reported flashes in their eyes at a rate of about 1 every 5 minutes. What these flashes were cosmic rays shooting through their eyeballs and setting off a cascade of reactions. And if that's going through your eyeball once every 5 minutes, you can imagine it's going through some part of your body every second. And it's just ripping apart molecules, essentially, and causing, it was going to cause extensive DNA mutation. So the cosmic radiation is pretty daunting. In terms of radiation in general, on Earth, we get about a REM per year between natural background, maybe some medical x-rays. The Apollo astronauts, again, they got a REM in about 10 days, which is bad, but they all live to an advanced age, so maybe not too bad. But on a 2-year trip to Mars, back and forth, living on the surface, we're talking about 100 to 1,000 REMs, and they're going to need some type of protection. The problem is, this is an engineering challenge. The problem is that protection usually comes in the form of mask, right? You wear a lead apron at the dentist office to protect that radiation from entering your body. But mass is going to be too expensive to add to these missions because mass means more fuel, and more fuel means more mass with that rocket equation thing going on. So there are some interesting possibilities. One that I found was the boron nitride nanotube, BNNT. This is very lightweight. It can be fluffy, or you can build it into actual hard structures. And it's just an excellent absorber of radiation. So you could insulate the whole outside of a spacecraft, or make it into tubes and actually have that be the structure of your spacecraft. And you can fill those tubes with water or hydrogen gas for even more protection. All great, it's just really expensive right now. So we have to figure out a way to create this stuff more cheaply. There's another more fantastic idea of creating a mini magnetosphere. The magnetosphere, of course, protects the radiation from entering the Earth's atmosphere. But CERN is working on these cables that can generate enough voltage around the spacecraft to act as that kind of magnetosphere. They're not close to doing it, but they're getting there. But we're still, 10, 15 years away from something functional that you could put on a spacecraft. Gravity, I told you about, is a major issue. I think NASA is insane with their idea that they're going to send people all the way to Mars in zero gravity. Who's going to get you off the, the rocket? I mean, look, this is astronaut Christine Koch. She's coming back after about a year on the International Space Station. She needs to be carried off. Who's going to carry you out of the rocket on Mars? There's no welcoming committee. Robert Zubrin has somewhat of an interesting, inelegant, but quite workable idea of a tether system where your spacecraft separates once it's out there and connected by a tether, and then starts spinning over and over itself to create an artificial gravity with centripetal force. That would work. NASA isn't even considering it. I don't know why. It's just deadly to think about what the gravity could do to these astronauts going to, the lack of gravity could do. Another thing people don't think about is what would happen if you need surgery. You can't do surgery in zero gravity, that's for sure. It's very difficult to do. The blood aerosolizes, and anesthesia would just be impossible to control. So it may be that we'll have to have prophylactic surgery, remove your appendix, as creepy as that sounds, and wisdom teeth, and maybe even gallbladder. Anything that could possibly go wrong, you would have to remove before you even leave Earth. It's a consideration. Oh, then landing. That's kind of tricky, isn't it? We never landed anything heavy on Mars, nothing heavier than a ton, really. And a lot of stuff crash, as you know. But when we're talking about human missions to Mars, we're talking about landing 20 to 30 tons, or Elon Musk's idea of sending rockets. That's 100 metric tons. We have no idea how to land that much mass. We've got a long way to go before we figure that out. Okay, how to get there? NASA's original idea was just to send everything, send the habitats and send the water and send the oxygen and send the gas to get back. And you can't go that way. You have to, all these kind of things exist on Mars. The water is on Mars. The fuel is on Mars. The air is on Mars if you make it. And that was this idea behind Mars Direct by Robert Zubrin, which you all probably know, where first you send this empty Earth return vehicle first, and nobody's on it. You send it, lands on Mars, a little robot comes out and starts making methane out of the carbon dioxide that's in the atmosphere and mixing it with hydrogen to make methane gas. That would be your rocket fuel to take off. 2 years or more later, when the astronauts come and they land in their habitat that took them there. And they also are carrying with them an unmanned, right behind them, an unmanned Earth return vehicle to start this cycle over and over again. They hop on, when they're done exploring, they hop on the first Earth return vehicle, and then the cycle continues. A new group of astronauts come with a new habitat, and slowly you build a village. I think that's a great idea, and maybe you guys have strong opinions about that. I know Robert Zubrin's a bit cantankerous, but I think he's gruff but lovable, in my opinion. It's a great idea. Walter, we're at that part in the video where I have to do a video, so I have to unshare this.
Yes.
Okay.
All right, I will now share.
So we're doing this to highlight how you could get to the moon for, Mars for free. Follow the green thing. Okay, I'll tell you when it's going to start again. Okay, it's coming around. The green thing's coming around. It gets going to take a couple years here, but at some point it's going to get close to Earth. And let it go around one more time. When it gets bang, it can pick up people on Earth and then follow the green, bang, deliver people to Mars in about 5 months. And then it's just a train in space. It never lands. It just goes round and round. It might take 2 years or so to get back from Mars, but it can still get to Mars. That's enough of that. It can still get to Mars in about 5 months. So what you have to do on Earth is when it's coming by, you jump up to it.
Okay.
Yeah, so you can quit that. And
Now
I'll share my screen. Yep. Okay. So that once it comes by Earth, you hop the train, you jump up there on your little shuttle, catch that train, that'll get you to Mars. And then when you get close to Mars, you jump down on another kind of shuttle. That's how you can move millions of people to Mars on these kind of shuttles, and not the Elon Musk idea of sending tens of thousands of rockets. I think it would just be inefficient to do it that way. You can have these massive ships, essentially, that are just always in space and never have to withstand the rigors of landing on Earth or on Mars. Okay. So here's the problem of Mars. It's beautiful. It looks too tameable. It's like Arizona or the Badlands of North Dakota. But it's pretty hard. It gives us this idea that we can conquer it, but it's quite more complicated. And we gloss over these a lot of concepts like the low atmospheric pressure. You see these stylistic spacesuits. Whenever anyone back on this, everyone's kind of in a slim pressure suit, but really you're going to need things that are as bulky as the moon at 6 millibar pressure, which is just marginally above 0 millibar pressure, not like the Earth's 1 or 1,000 millibars. I mean, this spacesuit over here was created by MIT, and we made a big splash in 2013. It doesn't work. It looks great, but it won't save you. You'll die if you wear that on Mars. It doesn't protect you from the lack of pressure. We need major work for pressure suits there. Otherwise, you're going to be in these big, bulky suits, and that takes a lot of the fun away from being on Mars when you can't even move your fingers and explore. The dust is just horrible. You know, who cleans these, who cleans the domes? Whose job is that every day? When you have a dust storm, that could block out the sun for a good 6 months. So what do you do about your food that you're growing or the energy you're trying to collect from the sun? It's not so simple. You have to come up with some redundancy, absolutely. And then the gravity, a wide open question of whether 38% is livable in the long run. There are interesting ways, places you can live. The first and easiest is just going to be send to habitats like I showed you. But you can remember that moon idea of these inflatables that you would cover with Mars regolith or even ice is what they're thinking about now on Mars, because you can cover with less volume of ice and water. It's denser than the regolith, so you could use less of it to cover your habitat and live in there. You do that in advance and get some robots to do it. So that's pretty interesting. You can live underground, of course. You have to protect yourself from the radiation, essentially. So underground, in caves, if you can find them. My idea is to dig into the side of a mountain, especially, if you're in the northern hemisphere, dig into the northern face. That way the sun is behind you, so you're blocking out all of your solar radiation, and you're blocking out most of your cosmic radiation because the Mars itself is acting as the shield from below, behind, and above. So you can put up like a massive window in your hillside habitat, which would be a great mental lift. Who wants to go all the way to Mars and live in a cave or live in a completely dark shelter with just a tiny window? You can have a massive view of Mars in these with these big windows. And I think it'll be easier to dig into the side of a hillside than to actually dig underground. There's lots of ways to make air. The atmosphere is mostly carbon dioxide. There's an instrument on its way to Mars now that's going to test an old-fashioned way to do it. Just convert that carbon dioxide into carbon monoxide and oxygen. The experiment's called MOXIE. I have no doubt that would succeed. But if that works well, they would scale it up to make, for the next mission, to make lots of oxygen that humans would be able to use and keep it stored on Mars. That's pretty exciting. This is really fun. The soil has these poisonous chemicals called perchlorates. And you can take that chlorine and oxygen that's in there, and you can mix it with bacteria or certain enzymes and create oxygen from that. You can envision these as kind of these emergency packs. If you're walking about Mars and your oxygen runs out or begins to run out, you can take out just your little bag of enzymes, pull up a bunch of soil from below you, and 6 kilograms of perchlorate can yield an hour's worth of oxygen. And this has been tested. Chris McKay of NASA came up with this idea. I saw it, it's really fun. He also has this idea of what you can fill the habitats with, this ratio of nitrogen, argon, and oxygen. You can get that ratio, it's 50 to 30 to 20, and that's a lot like Earth's 80 to 20, isn't it? Nitrogen to oxygen on Earth, or argon is inert, so you can combine the two and have that kind of ratio simply by removing the carbon dioxide and the carbon monoxide and add a little oxygen back. You could get that perfect ratio to fill up your habitats. I call it the K cocktail. I hope that catches on. Or you can do air the old-fashioned way with plants, and you can eat them. I visited University of Arizona to see this magnificent device. This is incredibly lightweight. I can lift it. It's aluminum frames that expand, and it is covered with kind of a plastic here. They got food growing with LEDs. They can harvest 1,000 kilocalories of food per day. And that same volume, it's about 6 meters long, 2 meters high. It can produce 100% of your oxygen needs for an adult in one day, and water. So obviously you wouldn't want redundancy on your mission in case the plants die. You want a backup source of oxygen. But each member of the crew could take one of these along with them, and it would have their own personal oxygen supply. And plus visually, to be on Mars with no plants is going to be really difficult. So to have this kind of mental lift, this taste of Earth and the fresh food they can provide would be a sensational idea. They tweaked this now. They even got mushrooms growing in here that can grow on the spent plant matter. So for a protein source, which is important because, you can't compost anything. This is hydroponics, so you don't really need the compost. So what do you do with all the plant waste, the inedible plant parts? Grow mushrooms on them. Very fun. Farming in general will be very difficult. You can't really grow potatoes in that soil because it has the toxic perchlorates. So even if he succeeded, Matt Watley from The Martian, he would have poisoned himself by eating those potatoes. The problem is that, the dust storms will block out the sun and you're kind of screwed. Or if you're relying on LEDs, they could burn out. So you're always relying on the Earth for your LEDs. I can't imagine Mars having their own LED production. So you kind of have to do kind of both and hope for the best with the dust storms blocking out the light. Very difficult to farm. Everything's going to be difficult, let's face it. So, I don't want to, sound like I'm kissing up to this crowd, but the first people that need to go, let's face it, are engineers. The engineers will literally know how to create a civilization out of thin air. NASA has some ideas of who to send for those first missions. A pilot to get you there, a biologist and a geologist to do some of the necessary science. That's why you're kind of going there. And then the chemical engineers and mechanical engineers that are crucial for establishing this infrastructure. I joked about IKEA being able to assemble IKEA furniture, but it's more so than to be able to assemble it. You need the type of brain that can visualize how to deactivate, deconstruct IKEA furniture and put it into packaging, the most minimal amount of packaging ever. You need that kind of brain that can visualize how to break things apart and then rebuild them. So certainly ordinary people are not welcome to Mars. You need some fantastic brains going there first. And the technology is not that's for sure. That came from the 90s. That was this idea of sending everything you need all at once. And there's no way you're going to get that kind of vehicle to Mars. But this is the kind of stuff that we need on Mars for us to live there. We're going to need major advances in automation, AI, better robotics. I mean, look at the rover. It moves along inch by inch. Landing technologies, avionics, even diggers. Digging is very complicated because the friction of the digger will start melting the water that's under the surface, and then that's going to vaporize and then freeze on the digger, and then you're stuck. How do you overcome that? In order to build these amazing cities like Musk is envisioning. How can this happen, really? You look at this and it's brilliant, but every single person living there is a moocher, aren't they? I mean, where's all the money coming from? It's coming from Earth. How are they going to make money to sustain this kind of civilization? What are they sending back? It's not like old world, new world, right? The new world could send back fur and timber and fish and that kind of stuff. What's the trade going to be? How are these people going to make money? That's a pretty big open-ended question. If there's no way to sustain yourself on Mars, how are you going to build the wealth to build these cities? I have open-ended question, that's for sure. That said, there are things that could make Mars a little easier. It's this near 24-hour cycle that they have, the day-night cycle, 24 hours and 37 minutes. So you could stick to a 24-hour clock just by making the Martian second a little longer, and you could have your regular clocks. The Earth is kind of a 2-to-1 ratio, excuse me, the year, 2-to-1 ratio. There's a tilt, just like Earth, 25 degrees instead of 23. So you have seasonal effects. That you can have your spring, summer, fall, and winter. It's going to be cold all season, but there are changes from season to season, absolutely. You could fly on Mars, can't fly on the moon. You could fly on Mars and ride in dirigibles. You got this canyon. That's certainly grand, man. That's the size of all of the United States right there. Massive canyon. They got mountains. Mount Olympus is 3 times larger than Mount Everest. And the landscape is brilliant, of course, pink skies, bluish sunsets, very stunning to see. Also neat is the moon Phobos is going to be crossing your horizon 3 times a day. That would be something to see, a moon that keeps on going by 3 times a day instead of once a day. And this terraforming Mars, very complicated, possible maybe even within 100 years. The idea is to add a lot of heat to liberate all the dry ice so that the carbon dioxide below your feet gets above your head. And I view terraforming as akin to being edible. There are plants that are poisonous and there are plants that are edible, and then there are things that are delicious. Well, we can move Mars from being poisonous to edible if we can move the atmospheric pressure from about 6 millibar to at least 150. So at least we could go out without a pressure suit and breathe 100% oxygen. Not ideal. I mean, Mount Everest is 500 millibar. So it's still challenging, but at least feasible, edible. But every millibar helps. And you can start at 100, start seeing bacteria, algae, lichen, maybe even plants and fungi, and have kind of an alpine forest if it gets up to 150. The thing is, the big problem, a real big problem, is can we do that? There's recent study that shows that even if you get every single bit of carbon dioxide up into the air, all the dry ice reserves, you're only able to increase the pressure up to 100 millibar, and that's not enough. It helps. You wouldn't have to wear as bulky as a pressure suit, but you can't go out without clothes on. Can't go out naked on Mars. And in the summer you could. Sometimes the summer gets up to about 60 degrees Fahrenheit. So it is, the temperature's there, but you wouldn't want to do it naked at 100 millibar. So that means you would have to import volatiles from an asteroid, like I was saying. And of course, that's next to impossible. But that's for you engineers to decide. Okay, so I'll wrap things up because it only gets harder after this. Mercury, we'll go back to Mercury. It's surprising in many ways. Mercury has the same gravity level as Mars, even though it's about the size of our moon. That's because it's so dense. And it's both hot and cold. It's not always hot there. The part that's not facing the sun is very, very cold. So, but because it's rotating so slowly, it's almost nearly tidally locked to the sun, not quite. So it rotates very slowly. And you could stay in that terminator line between night and day and only move about 3.5 kilometers per hour. You could walk it and you would stay in a perpetual dusk or a perpetual dawn, right at that nice temperature in between night and day. And that is quite feasible. What are you going to do there? I have no idea what your occupation will be, but that's where you would have to live if you're on Mercury, in some type of moving caravan, always moving. You don't want to stop. If you stop, you're toast in more ways than one. Venus, also surprising. It's hellish below at 400 degrees Fahrenheit all the time because of the atmosphere and the greenhouse effect. But at 50 kilometers up, it's only about 50 degrees Celsius or 120 degrees Fahrenheit. And that's livable. And the pressure and gravity is the same as that is on Earth. So that's kind of exciting. The only problem here is that, well, this is a NASA concept, a high altitude Venus operational concept, HAVOC. That's a great name for it. Should one of them pop, then it would be havoc as you tumble down into the to the ground. But you're really not like that if you're on Venus. At 50 kilometers up, you'll be in the middle of the clouds. That means you can't see the sun or the stars, and you can't see the ground below you. So why go? Why go all the way to Venus to live there just to be in the middle of an acidic cloud? So there's really no emotional motivation to get you there. You might have a science camp in these kind of balloon cities, but certainly no people living there, as easy as it might be because of the pressure and the gravity and the temperature. Ceres is the largest asteroid just beyond Mars. It's a dwarf planet, so large, it's now considered a dwarf planet. Still, the gravity is only 3% that of Earth's. Really no reason to be there. Maybe there's a possibility of life in a subsurface ocean. They detected tholins there, which is a theorized chemical that may have existed on Earth that gave way to amino acids. They detected them on Ceres, so it's worth checking out. But again, why live there? In science fiction, people live there as kind of like an asteroid mining base. But the low gravity, you can't stay there that long. You can do asteroid mining just as easily as on the moon. So there's really no need to be on Ceres. Same idea with Jupiter. They have had many moons, 4 captivating moons, the Galilean moons. The thing is, they're all low gravity. They're all just bathed in radiation from Jupiter. You're in Jupiter's magnetosphere. It's like being in the Van Allen belts, constantly bombarded with the radiation from Jupiter. And what's intriguing out there, of course, is Europa, you may know, has a subsurface ocean. So that means there could be life under there. How do you reach it? Good question, because that ice is really, really thick and as hard as granite. And it's, 10 to 100 kilometers thick. There's nothing like it on Earth. Lake Vostok in Antarctica, that ice is only 3 kilometers thick. We've just about penetrated that, and we're working in a balmy minus 50 degrees down in Antarctica. This would be a minus 180 degrees Celsius, much harder. So the only thing, of course, if there's life discovered there, maybe even large life, maybe you can have tourists out there on a submarine. We're talking hundreds of years from now, but there's really no reason to be living out there. Callisto doesn't get that much radiation, about 10 times higher than the Earth's. So you can set up a communication base there and then travel, take day trips to the other moons. Getting into science fiction here. Saturn's moon, Enceladus, it's actually a better candidate for life because they have vents, geothermic vents that they've discovered. And that could be a source of food if there is life. Problem again is the gravity even lower, only 1% gravity compared to Earth. So no reason to be living there whatsoever, but certainly worth visiting, especially if there's life. Some of those ice plumes blow up way up to Venus's rings. So some of those rings of Venus actually form from the water shooting out from Enceladus. That's pretty wild. Titan, people think that it's possible to live on Titan, and it's better to live on Titan than on Mars because Titan has an atmosphere. And I think that idea is really, really stupid. Yes, it has an atmosphere, and yes, it's 1.4 times that of Earth's, which is nice and thick. Like internet connection's getting unstable. I hope you can hear me. But who cares if you have pressure when it's minus 180 degrees Celsius? You're going to be bundled up anyway, so you might as well wear a pressure suit on Mars. It's really neat. These are lakes, absolutely stunning, larger than the Great Lakes. These are lakes of liquid, and they have rivers and clouds and rain. It's just that the liquid is in water. It's a methane and ethane. So you can sail on it, pretty fun, huh? You could swim in it, just don't drink it. It's just a fascinating place to be, but you never want to live there. Because of the low gravity and the atmospheric pressure, you could actually fly on Titan. So that would be one fun thing to do there if you were there. Or a flying bicycle. You could just have artificial wings and fly there. It would probably be the best form of transportation because walking on Titan, the heat of your foot would melt the ground below you, and then it would quickly freeze around you. So you would probably get stuck in the muck if you were walking on Titan. The other wild thing is that your habitat would have to be anchored down because the heat inside your habitat compared to the cold external area, it would actually cause the habitat to rise up like a hot air balloon. So wild place, Titan, but there's no reason to be living there whatsoever. And we just won't be doing it, even though it's kind of feasible. And then things just get, crazy. Cold is cold, isolated is isolated, airless is airless. I'll just leave you with a couple fun ideas. You could, sail above Uranus because the gravity is about the same as that on Earth's. Even though it's bigger, it's all gas and it's not as dense as the Earth. So for whatever reason, you could be above Uranus. But it's really neat. You could connect a tether between Pluto and Charon because they are tidally locked to each other. So their same faces are always showing to each other as they rotate around each other. So that tether, it's only 19,000 kilometers. And you could do that with Kevlar right now. And you could tether the two and live on some type of rotating habitat in between. Why would you do that? I don't know, aside from it being really fun. And you could have kind of a normal life in regular gravity and then make these day trips to Venus or Charon to just ride down the cable to explore. Another idea is if you're way out there in the Oort cloud. The Oort cloud is beyond the solar system, and there are millions of rocks out there, some as large as Earth. You could be hiding there if the time comes when there's an evil overlord taking over the solar system, right? Enslaving all of humankind. You could be living out in the Oort cloud in a tiny little rock. No one would find you. It would literally be like finding a needle in a haystack. It's so vast that could be your hideout for you and your rebels until the time comes when you're ready to overthrow the overlord. So that might be the most practical idea that I showed you in the last 10 slides here. Because of this, terrestrial chauvinism, I'm wrapping up at this point. This idea of living on any possible planetary body that's out there is just silly. It is Isaac Asimov came up with this term, terrestrial chauvinism. Why would we live down there when we could live in orbiting cities with artificial gravity? You can make them into like a Garden of Eden. I mean, look at this one. This one has patio furniture. Imagine that. I mean, but you could if you had the technology to be living in habitats and building a tethered ring on Pluto, between Pluto and Charon, you would be able to build these kind of habitats, these orbiting worlds all through the solar system. And you would choose, emotionally, you would choose to live on them in comfort than to live in the harshness of some of these worlds on the surface. You can make your day trip, you can explore these places, but there'll be absolutely no reason to live anywhere beyond Mars, in my opinion. It's just fascinating that people try to dream up these ideas of where we could live. So I'm back on Earth, back on the moon looking at Earth. I'll leave it here. I like this picture. This is a different alternate version of Earthrise. It's not the famous one from Apollo 8, the first picture, but this is from Apollo 11. But it just goes to show you what you would see on the moon every day if you were living there. And that's unique because in no situation was a colonist able to see the motherland. In the Americas, we couldn't look back to Asia or England. You couldn't see it. It's pretty distant. And even on Mars, you wouldn't even be able to see Earth. It'd be a little speck in the sky, a little star, it looks like. But on the moon, you would always be able to see the motherland. And I think that would be incredibly comforting. So I'm going to leave it at that. I want to thank you very much. I'm afraid I did run a little long. I was not paying attention. I apologize. No one stopped me, though. So, but I'm wide open for questions if we want to entertain them.
Yeah, absolutely. If anybody online has questions, you can type them into the YouTube chat in the live stream. And there's probably about a 10-second delay or so it might take a few seconds for them to get to it.
Should I open up the YouTube now? Oh, I see myself. No questions, alas. About Chris, Walter, any questions for me?
Well, there will probably be some questions, but they might materialize later after people get to see the YouTube. Chris, there's a way for them.
The one just came up.
Okay. You can read it for me, Chris. Or?
Okay. What is your view on transportation throughout the solar system? Highways, personal ships, maybe?
Virtual ships, I don't know exactly.
Personal ships.
Oh, personal ships. Yeah, I like this idea of solar sails. And I think we've proven that these are quite feasible, that we've even sent a solar sail into the wind, so to speak, towards Venus. These things can pick up a lot of speed at no energy cost whatsoever and take us all around the inner solar system, absolutely. And then there are newer technologies coming around like ion propulsion. And NASA has done well here. They had an asteroid mission using ion propulsion in which little xenon particles come out of the back, puff, 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 one at a time, but you build up enough and suddenly your spacecraft is moving rather quickly, faster than it would be with other kind of chemical propulsion. And you can do a lot of fine maneuvering that way, but also after some time, pick up a lot of speed. So I think between solar sails and ion propulsion would be a very interesting way to get around the solar system.
All right, we have another question here. Would power collection and beaming back to Earth be a possible economic way to fund space activity?
Yeah, there's, with everything, there's caveats, but perhaps you're referring to, power production on the moon or in low Earth orbit. And with low Earth orbit, of course, the solar collectors, all quite feasible. There's interesting ideas of, because it is never a cloudy day in space, right? So you would have maximum efficiency on these mirrors, and you could, on these panels, you could actually have mirrors that are focusing on some central collecting panel for the energy, and then you would beam that down to Earth in the form of microwaves. And that's all quite feasible, and there's very little energy loss with that. The only problem, so to speak, is the possible danger. I mean, you heard about windmills and birds, right? So you're going to have a microwave beam coming down from space to some type of central collector in some open area in the United States or in a desert or something like that. So it's just very hard to coordinate and make sure nothing goes through that beam. No airplane goes through it. Any bird that's going to go through it's going to be toast. But you might have some wildlife loss. So it's a little bit dangerous, but quite feasible. Same as on the moon, you could have solar panels on the moon and beam that to some relay station in low Earth orbit, and then bang back down to Earth. Or as I mentioned, nuclear power on the moon, because you don't have to worry about an accident, because if you're living on the moon, you're essentially living in some self-contained unit. So you don't have to worry about any radiation outside. So that could be a lot of money. That was O'Neill's idea with the with these rotating habitats. Gerald O'Neill in the 1970s, he wanted to build these O'Neill cylinders that seemed quite possible when the idea that the space shuttle was going to get us cheaply into space. It didn't work that way. But that was the main occupation of the people living in these orbiting cities, is taking care of the solar mirrors and other kinds of energy sources in space.
All right, our next question is, what is your view on fusion technology in the next coming of years, and what ideas are revolutionary?
Yeah, you've perhaps, the person asking has heard that frustrating quip that, fusion energy is it's the energy, it's always 20 years away and always will be. We've been working on fusion a long time. But some people who are really smart, smarter than I am, feel that fusion honestly really is very close. And it's a matter of putting more research dollars in it. University of Wisconsin, for one, feels that they're very close to being able to produce fusion, get more energy out than they are putting in. I mean, it's possible right now, but of course, you're putting a lot of energy into it to get the energy out. I don't know the technologies well enough to know what's really exciting in this, uh, other than there are people that are working on it in a startup kind of way. Private industry is now looking to get into this as well, to pick up the slack of a lack of government funding. I think the only thing holding it back, I don't want to be cynical, but energy is dear to the government. And our government right now, for whatever reason, for good reasons, they want to guarantee a supply of energy. And that's easily done with oil and coal, let's face it. So to jeopardize that and to research a lot of money, put a lot of money into research for these alternate forms, isn't such a keen idea for some politicians and some business leaders. And I think for that reason, it's not happening as much as we would want it to be. And it won't happen until something starts, it's the way human nature is. We really start to, it gets too late and we really have to start thinking of another idea to replace oil.
Yeah, I think we have a follow-up from the second energy collection question. Can you beam the microwave energy to other bodies, creating a sort of system-wide energy network for ships, stations, or land infrastructure to use?
Oh yeah. So it's getting a little ahead of ourselves, but of course, that was the idea to power these solar sails with lasers on Earth and send them at near, breakneck speeds across outside of the solar system and beyond. But yeah, this is real energy you could be using to beam spacecraft. And there's a far out idea. And again, it's not that it's science fiction. It's just hundreds of years from now. If we're spread out across this whole solar system, and I talked about the outer solar system and the Oort cloud, what could you be doing out there? If you want to create these interstellar highways in between star systems, you would need beacons, kind of lighthouses. And the lighthouses would be pushing off these powerful lasers, perhaps powered by fusion. And the ships would be able to catch them and be propelled by them. And so people could be making money as as those who are enabling the transportation of ships from star system to star system, propelling them with high power lasers. So, I mean, that's an idea that people talk about that's out there.
And I do actually have a question myself. I know you talked about, the first people we need to send are going to be engineers and scientists and pilots, which is kind of the way we currently do things. And a lot of the people are currently talking about starting, obviously low Earth orbit is cheaper. Anybody with 50 million bucks can go up there. But the idea of sending people like artists and musicians, I know there was the one guy that had paid SpaceX for a trip around the moon, but as not necessarily for a scientific purpose, but to get people interested. That if the moon eventually becomes 500 million per person to send them there, I think it would be beneficial just to get humans behind it and to have that artist. Like we were lucky with the one artist that was a Apollo astronaut, and his paintings are amazing.
Yeah, so. Absolutely. I love that idea. The Dear Moon Project, it's called, with that billionaire from Japan and the artists and his friends that will go along for the ride. I absolutely believe in that, and to motivate people. Of course, when I was speaking of it, I meant the very first people on Mars really have to be people that know what they're doing, and not someone that doesn't have some very important skills. Now, there's no reason why engineers and biologists can't have a strong artistic side as well. I mean, look at the photographs from Apollo's Earthrise, right? I mean, that's the image that can launch 1,000 ships right there. And that's that's a pretty artistic shot. And that's art that's captivating us to travel. All these pictures from space really inspire us to get out there and to treat Earth as something very special when we see how fragile it is. So I definitely would want to see more artists and writers out there in space when the time comes. Not the very first, for practical reasons.
Yeah, maybe the third or fourth Mars mission we can throw a painter or musician or something in there.
Mm-hmm.
And like you mentioned, it's also like if you look at Chris Hadfield's videos, those things blew up huge. Everybody loved watching him
Yeah,
sing in space, and he's also a pilot and an engineer. So it's definitely
that's
possible to be more than one thing.
yeah. They
That's all
say
those
that a slight mistake on that NASA did with Apollo 11 was choosing Neil Armstrong over Buzz Aldrin to be the first one to walk on the moon. Everyone knows Neil Armstrong's name. Our crowd knows Buzz Aldrin, but a lot of people don't know who that is, that he was the second guy, right? You never remember the second guy, you remember the first guy. The thing is, Neil Armstrong was kind of an introvert, and he did not immediately go out and talk about his exploits. Where Buzz Aldrin, he's just sensational, isn't he? And he's out there motivating people all the time. He's still alive, of course, and he's still fascinating individual. I know he's slowing down now. He must be close to 90 years old. But that was an unfortunate little situation where NASA's lead guy did not really sell the moon the way that Buzz Aldrin could have done it.
Hey, I had a question too. I looking at your orbital rings.
Yeah.
I have done a paper on the Jovian electromagnetic rings where you put orbital ring around Jupiter, and with that intense field, if you can lower electrostatic or cables and produce a lot of power just by intersecting the Jovian magnetic field that you're rotating.
Really?
That was the paper I did. It attracted interest. This was back in 1990.
Uh-huh. That does sound really neat. Yeah.
But yeah, that must it would more likely than not you would have to export the power because you couldn't have humans habitate that close to Jupiter. The radiation is too strong.
Yeah, that's right. I saw with Io was like 3,600 rems per day.
Right. It's terrible. Okay, well, I really liked your presentation, and we got more questions, Chris, or how long are we going to go?
I'm good if there's more questions, but if you have to cut off, I understand that too.
We do have one more question that came up.
Yes.
Where and when do you think the real interest in space from the civilian aspect will kick in?
From the civilian what?
From the civilian aspect. So I guess, we're all kind of space nerds probably for watching this, but
a year and a half now. It's, of course, I can't put a date on it, but it's incremental. It's inch by inch every day with people like Elon Musk. When he launched that Tesla into space, that was a real sensation. I know that was pure showmanship, but that brought a lot of interest. And this idea, I think, in the next couple of years, when more people start getting up into space, I know they're going to be billionaires and multimillionaires, and we're not particularly close to them. But just seeing more people having fun in space, if they could ever pull this off with the Mission Impossible movie, I think that's just going to blow it out of the sky, so to speak. I mean, when you see a movie actually filmed in space, I think there's going to be incredible interest for the civilians to start pleading with their government to find better ways to better access into space, because it just feels like there's this stagnation, of course, 50 years after Apollo, and we're still not there. I mean, President Trump is tapping into it, right? He with the Space Force, and it's practical on one level because there's dangers in space. We have a lot of assets out there that can be destroyed, and they might need to be protected. but at the same time, he's capitalizing on this thrill that many people have in the United States and around the world of having more activity up there. I do feel that people feel that we've done nothing, even though we have done a lot. But people feel that because we're not on the moon, we haven't done much in the past 50 years. And so I do think there's a huge civilian market for this kind of excitement.
And I will add, I think it's definitely started over the last few years.
Mm-hmm.
I know when I was at UCF as a student, we would drive over to watch the launches 45 minutes away at the coast.
Right.
And there was a big launch of a Delta IV with the Orion prototype on top in 2014, so about 6 years ago. The park we went to probably had 50 or 60 people watching that launch. It was a big deal. Now, if I drive by that park, I live out by the coast, and just over the last 5 years since I've worked out here, every launch is like that or more.
Really?
You can't park within 100 yards of that park anymore. Like, you can't park at restaurants because people are all crowding the parking lots to go across the street and get as close as they can.
Oh, that's a real.
They've had to move the security checkpoints back to where they were during the space shuttle program and the Apollo programs, because people were crowding the causeways and causing too much traffic for the people trying to get into work. So it's just in 5 years, it has definitely doubled or tripled the people that launch an average or watch an average launch.
Yeah, that's really indicative of something big.
I think it's going to greatly
galactic too, you know.
It's going to greatly, once we get the snowball effect going with missions to the moon on a regular basis, the interest in space will pick up.
Absolutely. And the space planes too, like Virgin Galactic, they had some setbacks, but you know, maybe in a couple more years, they're going to have the suborbital flights. They already have people buying tickets. There's a balloon idea too of taking a stratospheric balloon, taking people up there for much cheaper. And you could see, you could get high enough, 90% clear to the atmosphere, and you can see the curvature of the Earth. Straight up, straight down.
Chris, you want to take a couple more questions or call it?
If they're there.
Stevens.
Yeah, we don't currently have any more questions online, so give them a few more seconds if they have any last minutes. Thank you so much for doing this tonight.
Oh,
really exciting to hear.
We really appreciate it, Christopher.
Yeah, no, it's great. People can always email me at wanjek@gmail.
Are you going to put in a plug for your book?
Sure. Yeah, well, that's my book, Spacefarers. Yeah, available at bookstores should you be able to actually go outside. It came out in April at the height of the pandemic. So, but yeah, you can get it, of course, by Amazon and places like that. It is in bookstores. Of course, it's published by Harvard University Press. So they got it at various places. It's part of their Universe series. It's been getting good press. A lot of good reviews that I was thrilled to get by, Physics Today liked it, and that was a real thrill for me. I like it when smart people like my stuff. Full page review in Science, Science News, Guardian. So I've been quite happy with the coverage. Everyone who read it has liked it. They find that it's certainly readable, slightly humorous, and practical. I'm pro space, but I'm not, so crazy about some of these ideas. I try to draw the line of what is feasible and what's really not that feasible, as you heard tonight.
Okay, well, great. I guess we're going to close this out.
Okay.
And I wanted to thank both Christophers for Christopher, the author, for presenting, and Christopher Stevens for putting this on YouTube.
Okay.
Yeah, thank you again for calling in. I do have up on the screen now Chris's website, christopherwanjek.com, has great info about all of his books, links to some of the articles he's written. I found it on Kindle, so that's actually how I found out about this book and the author. So it's out there, available now. If you want to learn more about our organization, I also have links up here to our website, Facebook, You can also email us at our AIAA.central.fl@gmail. If you have any questions or comments or anything, or ideas for future events. Thank you everybody for participating and for all your questions. And we hope to see you again soon in a future event.
Yeah, thank you again.
Okay, thank you a lot. I'm going to terminate the Zoom recording. Bye.
Bye.